Hi all, I am Mr. Manideep Gupta, Assistant Professor, Department of Aeronautical Engineering from MLR Institute of Technology. In the series of lecture Aerospace Propulsion 1, today we are going to discuss about the topic motion of bodies in space. In the previous lecture, we have discussed about the Newton's law of gravitation and how different bodies attract in the universe. Each body attracts the other body. So the resultant will be acting on the all bodies. So now how the motion of bodies happens in the space we are going to discuss here. So the overview of presentation, motion of bodies in space, parameters describing motion of bodies in motion of bodies. So coming to the motion of bodies in the space, the first one is laws of planetary motion. So after Newton's law of gravitation, there is a description about the bodies, how the planets are moving in the space by Johannes Kepler. So in that, the first one is law of eclipse. So here you can see the sun is at the center and the planet is revolving in the elliptical path. The second one is law of equal areas. So what is law of eclipse? The paths of the planets in the solar system about the sun are elliptical with center and sun being located at the focus. So if you take the planets, our planets like Earth, Mars, Jupiter, etc., all are rotating around the sun. In an elliptical path. Okay, sun is located at one center. So if you consider any elliptical shape, it will have two centers. This is center 1 and this is center 2. And we considering here, according to the laws of eclipses, the sun is located at one center, that is focus 1. Next, second law of equal areas. So according to the law of equal areas, the imaginary line from the center of the sun to the center of the planet sweeps out equal areas in equal interval of time. So if you draw an imaginary line, an imaginary line from the center of the sun to the center of planets. So if I consider this is the center sun and I am considering one planet here and another the same planet here, is rotating in this direction. So at time t, the planet here is at time t1 here, and after some duration of time, the planet reaches to second position at time t2. And here this the same planet after some time it reaches to the third position at time t3. This is the third position, and after some time it will come to the fourth position at time t4. According to the law of equal areas, if you draw an imaginary line from the center of sun to the center of planets, so this is an imaginary line. Consider this is an imaginary line. It sweeps equal areas in equal interval of time. So if I take the time t2 minus t1, t1 is equal to some capital T. And t3, the time taken by the planet from third position to fourth position, is t4 minus t3. And if the times are same, this is also equal to t. T2 minus t1, that is the time taken from the for the planet from position 1 to position 2 is capital T, that is t2 minus t1, and the time taken for the same planet to move from the position 3 to position 4, that is t4 minus t3, that is also equal to t. Then the area swept by this line, this is an imaginary line, right? So this is an imaginary line at the position 1. If we sweep this line from position 1 to 2, this is the area covered in the first case. And if you sweep the line joining from position 3 to 4, this is the line joining from 3 to position 3 from the center, and this is the line joining to the position 4 from center. If this line is sweeping area from 3 to 4, consider this as A2. Since T2 minus T1 is equal to T and T4 minus T3 is equal to T, then automatically A1 is equal to A2. That means the planet is sweeping equal areas in equal interval of time. So this is the law of equal areas. If it takes time t, it covers area A. Then if the same time taken from position 3 to 4, the same time, then this area will also be equal to capital A. So that is a law of equal areas. Next, coming to the third one. So that is law of harmonies. What is law of harmonies? So the ratio of square of the orbital period of any two planets is equal to the ratio of the cubes of their average distance from the sun. If I consider the orbital period as t and average distance, that is semi-major axis, or the distance from the planet from the center is r. Okay, if I consider the elliptical path like this, and this is the center, okay, this is planet 1, P1, and I am considering another planet revolving in the elliptical path. This is planet P2. Okay, according to the law of harmonies, the ratio of the square of the orbital period, suppose take this planet 1 will revolve around in the orbit in a time t1 for one revolution, and if we consider the planet 2, it will take a time period of t2. Okay, so according to this ratio of the squares of the orbital periods, that is t1 square divided by t2 square, it is a ratio of the orbital square of the ratios of the orbital periods is equal to the ratio of the cubes of the average distance from the sun. So what is the average distance? Suppose if you consider the planet P1, this is the average distance, that is R1, and second planet, the average distance is R2. So cubes of the ratios of the average distances. So it is equal to cubes of the radius R1 cube divided by R2 cube. So according to this law of harmonics, T1 square by T2 square is equal to R1 cube by R2 cube. The square of the ratio of square of the time periods, the ratio of the squares of the time periods is equal to the cubes of the average distances, the ratio of the cubes of average distances. This is called law of harmonies. So this is applicable for any planet. It can be, here you can imagine the planet Earth and Mars. You can imagine the planet Mars and Jupiter. You can imagine any planets in the place of P1 and P2, and this law is applicable. So this is about the next topic is parameters describing motion of bodies. Parameters describing the motion of bodies. Suppose if you consider any object, okay, I am considering one object here. It is moving with some velocity v. It is moving, right? So how I explain the motion of that body is, okay, I can say this body is moving with velocity v, and another parameter is it is moving in a such direction. Suppose x direction. It is moving in the direction x. Like this, I have to describe the motion of a body. So there are some parameters by which we can describe the motion of a body. So the parameters describing the motion of bodies are velocity, momentum, and acceleration. Okay, so if you consider the first term, velocity, okay, velocity and acceleration both are derived from the length and time. So velocity v is equal to distance traveled, that is length by time, and acceleration a is equal to change in velocity with respect to time. Okay, this velocity and acceleration both are derived from the terms length and time. But if you imagine the velocity is not alone can explain the motion of a body. Suppose, for example, I will take one surface here, okay, and imagine a small stone and imagine a big stone. Both are at equal height. Both are at equal height h. Okay, both are at equal height h, and if I drop these two stones, it will hit the ground with some velocity v, and both the stones, small stone and big stone, both will hit the ground with the same velocity. But the impact created on the ground by the small stone is less, but the bigger stone, this bigger stone is more on the ground. That means velocity is not alone can explain the motion of a body. So we need some extra parameter, that is nothing but called momentum. So what is this momentum? Momentum is nothing but a linear momentum. Here we discuss linear momentum. Momentum is product of mass and velocity. So if you consider a body, big stone, it has mass m1, small stone, mass m2. So the momentum of small stone when it hits the ground is m2 into v, and the momentum created by the big stone when it hits the ground, that is mass m1 into v. So even though velocities are same here in the two cases, but masses are different. That is why the impact on the ground is different. So it has more energy. So that's why mass is also one of the important parameter which has to be included while explaining the motion of body. So that is why this parameter called linear momentum or momentum is very, very important to explain the motion of a body along with velocity and acceleration. So this is about today's topic. So coming to the summary of today's topic. So we have discussed laws of planetary motion. In that we have discussed three laws: laws of eclipse, laws of equal areas, laws of harmonies. After that we have discussed the parameters describing motion of bodies. In that we have gone through velocity, momentum and acceleration. So this is about today's topic, and we will continue in the next lecture.